I'll be talking about Numpy. Now, Numpy will help us to do basic mathematics like, you know, matrix multiplication, array multiplication, and so on and so forth, whereas SciPy has advanced statistics in it. So, I'll be covering Numpy almost in details, but when it comes to SciPy, I'll just be explaining you as to what it is, because first of all, the first criteria is, you'll have to know what it is, right? Standard deviation, coefficient of variation, so on and so forth. Now, lot of derivatives, etc. You'll have to know all those functions in order to be able to understand SciPy. But regardless of that, I'll be taking you through it at a high level, and then walk you through matplotlib by drawing few graphs. Now, see, this is how, by now you must know as to how to install Numpy, or if you are lazy as to do this, just go to your PyCharm and then install Numpy. Okay, but there will be a couple of dependencies. Okay, make sure that you have installed all those dependencies, and only then you will be allowed to install Numpy. And for other folks, if you really find problem with this, what I would suggest is go to okay, just go to this website, right? ifd.uci.edu, and then go to the corresponding. Just give me a second, please. I just want to show you how to install it. So Numpy is fundamental package needed for scientific computing with Python. So whichever version suits you best, right? Just download that and install it. Let's say, for example, if you are doing SciPy, in SciPy, a software for mathematics, science, and engineering requires Numpy MKL. So it says it requires Numpy MKL to install before you install SciPy. So basically, just install this first and then install SciPy later. Okay, make sense, guys? Anything that you are not able to install, matplotlib, also, everything is there. This is a gold mine that I found. And then before you install matplotlib, it requires Numpy, date utility, py, pz, parsing 6, and optionally all these packages. Okay, so that's about it on how to do the installation. Or you can obviously go and do sudo apt-get install python numpy. Now, Numpy is an extension to Python programming language, adding support for large multi-dimensional arrays and matrices. Okay. There is, okay, you are using sudo, right? Super user here. Sudo will ask you super user password. Is that okay? Okay, I'm Numpy for statistics and SciPy for machine learning. This is for large multi-dimensional arrays and matrices, right? It supports arrays and matrices along with large library of high-level mathematical functions to operate. So mostly Numpy would be younger brother of SciPy. Okay, SciPy is like the big brother. It has all those statisticals and big functions. Numpy would give you all the basic stuff. That is what you need here. Numpy is a fundamental library needed for scientific computing with Python. It contains n-dimensional array object, array slicing methods, array reshaping methods. We'll see that one by one. Numpy routines, linear algebra, Fourier transformation, random number capabilities. We'll see that as to what they are. Now, this is something that which might interest you. Okay, so I have like always, what I do is I make a note of these things. This is much more than what's available here, right? And which again I'm going to share it with you whenever you have time. Just go through this once, and you'll be able to at least understand high-level overview of what a Numpy and what a matplotlib is. Only for SciPy, I have not given anything here. The reason being is that SciPy is completely statistics, right? It will not have made sense for me to put anything here for SciPy. So here multiple plots, etc. So let me start with Numpy. And even in Numpy, some of the stuffs are here already, right? And some I have it here. So let me do a basic, let me take you through some of the basic steps here and then walk you through that. Is there something like yum where auto resolve dependencies in PyCharm? There will not be any auto resolve here, but it will be able to auto fill your whatever functions that you are trying to call, Krish. There is no auto dependency. You'll have to do it manually. Yes, I got it actually. I got it on the second step. So there is no auto dependency resolving in PyCharm. No, it's not even in command line. You'll have to do it explicitly one by one. With the latest edition, I'm not sure with 3.4 edition if it is there, but with the older installations that I did, it's not there. Even I was looking for that actually, while I was trying to install, because this is a new system setup and I had to do everything one by one manually. So I was trying to find out, I could not figure out anything for the older versions, and for the newer, I have not checked it. Okay. So coming back to the problem here now, you see this arithmetic operation cannot be directly applied on list, right? Let's say I have list 1 and list 2 and then I do a list sum. What does it do? We get a union of list 1 and list 2. Okay, but hence we need efficient arrays with arithmetic and better multidimensional tools. Numpy package provides arrays which are similar to list but are more capable except fixed size. Okay, in this case we have list 1, list 3 is this one, and then when we print this list 3, okay, let me take you this one by one. This is list, this is normal list, okay. List 2. See, list 1 has 5, 6, 7, 8, 9, list 2 has 1, 2, 3, 4, 5, and when I do an addition of list, what happens? It just does a normal addition. It says 1, 2, 3, 4, 5, which is from the second list, and 5, 6, 7, 8, 9, which is from the first list. Now, what happens if I do the same thing in Numpy? Okay. Now, you see this list. Okay, let me take this from here. A, and if I print A, I have array of 1, 3, 5, 7, 9. That's my A. Okay, watch this closely, guys. B. Okay. Now C. Now what happened? Interesting, isn't it? I just did an addition of two arrays here, and then actually added 3 plus 1 4, 5 plus 3 8, 5 plus 6 11, 7 plus 10 14, and 9 plus 9 18. So array addition. So first thing that's available in our Numpy. Okay, and if you look at here, it's just you know all this. Okay, you know this already. List 1 to 4. It will give you all the items from 1 2 3. 1 2 3 is 8 7 6. List 3, you can have list within a list, and then you can print list of 0, and then you can say list of 1 1 2 4. So you know all this. We have gone through list. These are functionality of list. Now Numpy's main object is ND array. We'll see that, and this is a table of elements all of the same type. We'll even look at the type as well. Dimensions, usually called axes, and rank, it's the number of axes. Example of multidimensional arrays include vectors, matrices, image, and spreadsheet. Now see, this is an array of rank 1, right? It has only one dimensional array. It's a, okay, it's an array of rank 1 with 1 row and 3 columns, right? This is 1 row and 1, 2, 3 columns. This is an array of rank 2 because there are 2 rank here. I mean, it's an actually 2-dimensional array with a matrix of 2 rows and 3 columns. Now we'll come to this while we are looking at the data. Let me directly go to the problem statement, and I'll come back, explain it one by one, because with an example you'll be able to understand this better. So let's say I'm creating a list. Okay, this is a list within a list, right? This is one list, 2 lists, 3 lists, and then this is a complete list. Now I want to make it as an array. Let me do how I can do that. Creating an array using Numpy. This is how I create an array using Numpy, right? Now what happens when I do an array? You have a 3 into 3 array here. What's the rank of this? It will be 3. Okay, so I created a 3 into 3 dimensional array. So I'm only trying to show you as to how different it is from list right now and what are the operations that you can do using Numpy. Now if I do an arr.save, right, it gives me, it's a 3 into 3 matrix. Okay, that's what it was trying to say here, you know, arr.save. We'll look at that. Now also I can say it's D type. One second, what's that? It is D type. Okay, arr.data type. It's, and this is of type int32, right? So these are the features that we have on array that that can be performed here. But let's go to other problem statement. If you do a, see how different is this, right? If you do a array of 0, you get 1, 2, 3. Array of 1, 5, 10, 15. So it's giving you row, right? You do not have array of 3, that's why it gave you an error. But if you have to print 2, it just gives you 10, 20, 30. Now you would ask me that I am able to pull this, right, on row wise. How do I pull it column wise? So let me see that. Now you see this 2, 10, 20. This is column wise fetching of data. Likewise to that, if I want to pull 0, it's 1, 5, 10, right? See here 1, 5, 10, and so on and so forth. Now how would I be able to access? I mean, all of you would have done mathematics at some point of the time or other in school, high school or college, etc., right? In there you would have done matrix multiplication or you know, addition of arrays, etc. So that's all I'm trying to do here right now. Now how would I access each of these individual items within that complete array? Let me do that. This is done using, it's exactly, I mean, this is how it used to be done in mathematics, and this is how it is done here in Numpy as well. Now array 0 of 1, this is 0 and this is 1, right? It's 2, 3, right? And if I say 0 of 0, that means array item, and let me again print an array for you. So my 0th row, 0th data, this is the one, array of 0, 0, 0, 1 would be this one, 0, 2 would be this one. This will be, how would I fetch this data, guys? How would I fetch this data? Any idea? I was able to fetch the first record with 0, 0, 0, 1 and 0, 2. So this would be 1, 0. Okay, that's not an array P, that's a typo here. Okay, so what did it get? 1, 0 would be for the second one. Now if I want to get the third one from third row, will be 20, and so on and so forth, right? So that's how you create an array in the first place. So what did we learn? We learned how to create an array. Basically, you'll have to put it inside a list. It will be list of a list, and then you call that numpy.array, right? You call numpy.array, pass that list, and it creates a a matrix type here. You can see the shape. It's a 3 into 3 dimensional matrix here, or an array, and finally you'll be able to access each item from within that array. Yes, Amit, it's like a matrix. Okay, it must be for array.shape. Which version are you using, Naveen? Okay, 2.7. I think it says 3 long type. And what's your data within it? Is it integer, float? Just 1 to 9 numbers. So it must be representing a data type, Naveen. You'll just have a look at the 2.7.8. Okay, it's the same as mine, but how is yours different? Mine is also Python 2.7.8 cell. Okay, array dot shape. It's 3 into 3, right? That's the matrix. Okay, yours is 2.7.7, right? So just maybe it's talking about maybe that is the problem. It's not a problem. Maybe that's how the representation is done in 2.7.7. Okay. So that should be okay. I mean, just having okay. Sure. You can check that out. It must be 3 list into 3 list or something like that, or maybe data type worst. And then see, I have written some more of this here. Okay, to see the whole list, you can do 0, 1, 0, 2, 0, 0, column 1. So you can try this out. I'll be sharing this with you. Right. Let me go here now, and now fetching the values from arrays using index. Array of 0, 0, 1, we have seen that, that's fine. Now array of 1 of 2 will have to fetch me 15, because array of 1 would be the second row, and 0, 1, 2. And so it's 15, fetching value of position 1, 3 in the array. Now updating the values of the column, right? So this is how you update the values of the column as well. Now how does our array look like? This is how our arrays look like, right? So what I'm trying to do, I'm updating the values of my column. So when I do an add, so I'm replacing the 0th column with 999 here. Okay, that's how you can do. Now that's again there here. It says updating the value of the column. Generating an array of zeros, right? All you have to do is that, oops. And if you guys remember identity matrix, I'll be talking about that as well. See, we are generating an array of zeros. 1, 2, 3, 4, 5, 6 zeros. Now what is this dot, right? By default it's taking floating point type. Okay, so if you do not want that floating point type, all you have to do is you have to just say 6, and then data type you have to point it out as int. Array numpy. One second. Why does it have data type equal to numpy dot int? Okay, fine. You see this now? By default it was taking this floating point, and when I wrote the data type as explicitly integer, it gave me a value of integer array. So that's about it there. Now if you look at this data type, okay, one thing I missed, right? Let me go back here. Let me define this. Array 1 here, and if I say array 1 dot d type, it gives me float 64, and this is my array. If you see this, if I go and say array of d type, because I gave it as integer, it by default will take integer 32. Okay. Yes, it will create a array of zeros. Correct, Vishnu. Okay. So if you put if you put these things in list, it will create a matrix for you. Okay. These are all simple examples here. Now this is generating an array of range. Yes, Vishnu, it's all there. I'm coming to you, Vishnu. I'm coming to that. It's dot I. Let me come there, Vishnu. There are a lot of examples here in this. I'll be walking through you all those things quickly. So if I have to generate an array of range, right? This is array of range, and it's 0, 1, 2, 3, 4, 5. Your idle screen to the middle. Okay, not able to see it properly, Amit. Okay, just a second. Okay. I'm not sure why we create an array of zeros. So like array of zeros, right, Vishnu, we can create array of ones as well. There will be particular use of it. Okay, at times we'll see at what times we are going to use those zeros, but it's not zeros that we have ones and twos, etc. as well. Okay. So Amit, are you able to see my screen now properly? Okay, great. Now see, if we have to generate an array of range, we can do that using array of a range. These are all functions which are already available. Okay, I'm not doing anything new here. And then if I have to say multiply array into 2, what happens? It just gives me 2. Everything it multiplies by 2. Did you see that? What happened? It just multiplied everything by 2 into 0, 0, 2 into 1, 2, 2 into 2, 4, 2 into 3, 6, 2 into 4, 8, right? What happens if I do double star 2? It's squared, right, Vishnu? That's right. So, and also we can also do one more thing as to, this is start, stop, and this is step over. Can we do star, star, star? Okay. For cubed, let me see that. So ARR star, star, star. I mean, I have not seen that, but and then you want to give 3 or 2. Okay. No, it does not work. It can work only up to 2. Okay. Okay. And excuse me. Okay. Sometimes while talking, the voice does not come out of my mouth. So I have to take a 20 seconds break. Anyways, that's about we can do. I just tried that. Vishnu, did you see this? Okay. There is. Okay. This will give you for 3. Correct. I mean, this is like to the power, right? Star, star, star is to the power 3. Okay. Now we'll see what is it that we are missing. Zeros. Okay, we did that. Okay, for ones, see, it's like generating a range of integer with value as 1. and then for range you have this. You can multiply it by 2.0, it will all be floating point, right? Generating an array of range with float values. See, this one is float by default, also it's float, so you do not have to worry much about it. If it's float, if it is integer or any other type, then you have to mention it as numpy.int. Now generating a range of array of range, start, stop, and step. So if you are saying 0 to 10, 2, it will give you 0, 2, 4, 6, 8. It's multiplied by 2. 2 ND array may be a view to the same memory. Okay, now this is one important concept. Okay, copies and views. Now what are those? Let's see that. Now I have one array. Okay, so this is an array. If I do an array 1, I have 1, 5, 7, 9. And then now let me assign array 2 equal to array 1. What happens? Array 2 also should have the same value, correct? And now this is just a plain assignment, right? So if I say here once array 2, array 1. So if I say array 1 is array 2, it says true. How is it true? Any idea? Give me basis of what it is. Going back to our previous class, right? ID of array 1 and ID of array 2. It's just a pointer. Absolutely, Vishnu. That's true. So equal. Exactly. So in this case, when I say array 1 is array 2, you look at the ID of array 1 and array 2. They are just pointing to the same thing. They are just pointing to the same address. So they are equal. Okay. Now ID of array 1 dot base. This is the base. So it's pointing to the same base as well. Okay, the IDs are same, the bases of that IDs are same, so it's all fine. We'll look into what's base. Now deep copy. Let's do a deep copy. Okay, there are two types of copy, which is called as deep copy and shallow copy. Now I have array 1. Array 1 is this one. And then if I say array 2 equal to array 1 dot copy, and this is the function, it becomes a deep copy. Now let's see. Array 1 is array 2. What happens? It's false. Why is it false now? Let's check the ID. ID is still not changing of array 1. ID of array 2 has changed because so a new array. Absolutely, Vishnu. That's right. So no magic, but let's see. ID of array 1 dot base is this one. ID of array 2 dot base. But at the end of the day, it is being copied from where? It is being copied from base location. So the base location is still the same, right? It has not changed. So we'll move on. So it's not now shallow copy. So at times, you just want to copy it, and so the arrays are pointing. Okay. At times you just want to copy it, use it, and then you do not want to copy it in a separate location altogether, right? Many times we do that. It's as good as a view, whichever view that you have used in any of your SQLs, right? View does not actually store the data, but it just refers to your base data, right? So let's see. Array 1 has this one, and let's say array 2 equal to array 1 dot view. Last time I did a copy. So if I do a view, here it goes, and then array 2 also the same thing. Now ID of array 1 is this one. ID of array 2 has changed. Now the view has a different location, but if I check the basis of this, it will be pointing to the same base again. Okay. Now here it says deep copy versus shallow copy, checking if they are equal. In case of deep copy, it's false. Checking if they are equal. In case of shallow copy, also this is false, but if we check the base, then the bases are same. Okay. So that's the difference between deep copy and shallow copy. Now you see this. Okay. Now I'm going to run you through this array 1 and array 2. Now you have this array 1, array 2, dividing the array by an array. If you do array 1 divided by array 2, it just divides 5 divided by 5, 5 divided by 5, and then you get array 1, 1, 1, 1, 1. Make sense? That's array division. Now using integer list as indices of an array. So let's say you have an array which is range 20, right? What will this give you? Array equal to numpy dot a range of 20, right? And then if you do error, you get value till 19. Now what does it do here? It says indices. That means you're just giving some number in indices, or I equal to your list of 1, 3, 5, 1, 3, 4. Okay. Now if you do, and where is I stored? Okay, array of I, it gives you 1, 3, 4, because I am pulling the 1, 3rd and 4th values here. So that's what it's saying, fetching the values of indices present in the list. So you can do that as well. You can put all the indexes in one list and then pull the data from there as well. Comparing the values of an array, you can do that as well. Array equal to numpy array of range, and then div equal to array modulus of percentage of 2 or equal to 0. Then you get true, false, true, false, true. Now if you look at this data, right, 0, 1, 2, 3, 4, divide by 2, 0 divided by 2, 2 is 0, right, it's true. 1 divided by 2 is not 0. 2 divided by 2 is true, false. 3 divided by 2 is false. 4 divided by 2 is true, right? And then it's of data type Boolean. Okay. And if you go a little further here, you can say array of div, whatever you got here, you would get 0, 2 and 4, whichever are true. 0 is true, 2 is true, and 4 is true. It's just basic mathematical operation on an array.